This is a fairly straightforward paper, maybe even intuitive. It talks about how the information about historical emissions drives the division of climate change mitigation costs. Everybody is engaged through the UNFCCC on climate change mitigation and through renewables and everything else. How do countries contribute to the mitigation costs? Obviously, the global south is looking at the global north and the developed world in terms of historical emissions and saying, you guys have been mostly responsible for the problem we have now in terms of increased greenhouse gases and global warming, so you should pay more. Even though this seems obvious, it's important to kind of go through the exercise of game theoretical approaches to see how fictional countries would play in negotiations, depending on whether they know that their ancestors, their country, their forefathers created the emissions problems along the way that they have inherited, and whether the poorer countries or developing world knows also that the emissions have mostly come from the rich countries, or they don't have this information at all. These kind of approaches are taken in resolving many conflicts on water, fisheries, sharing of natural resources, or common goods in many ways. Very nice work from Eleanor Ostrom, who won the Nobel Prize, passed away a few years ago. Marco Jansen, who worked with her and is now one of the leaders in this field. Agent-based modeling, etc., all come out of these ideas. So reading with the abstract first. Despite worsening climate change, the international community still disagrees on how to divide the costs of mitigation between developing countries and developed countries, which emitted the bulk of historical carbon emissions. If you look at cumulative carbon emissions, the developed countries have mostly been responsible for what has accumulated thus far. We study this issue using an economic experiment. Specifically, we test how information about historical emissions influences how much participants pay for climate change mitigation. In a 4-player game, participants are assigned to lead 2 fictional countries as members of either the first or the second generation. So those who were already aware that their forefathers emitted all these accumulated carbon, and the second generation which may not be necessarily aware. Now everybody is aware because of the attention to climate change, so nonetheless it's important to play these games to see how perceptions depend on what information there is and how various behavioral aspects like rational ignorance will play. In other words, you know that you are responsible for something, but when it's a shared cost, you just play ignorant and say, I don't know that happened. The first generation produces wealth at the expense of greater carbon emissions. The second generation inherits the predecessor's wealth and negotiates how to split the climate change mitigation costs. Here we show that when the second generation knows the previous generation created the current wealth and mitigation costs, participants whose predecessors generated more carbon emissions offered to pay more, whereas the successors of low carbon emitters offered to pay less. Well, this is an ideal situation, of course. In the real world, rich countries are not necessarily stepping up to pay for the mitigation costs, or even things like loss and damage, where adaptation costs to countries like Pakistan, which got hammered by heavy floods in 2022, and their inability to adapt to these kind of massive catastrophes, right? So I'll briefly just go through the results and few words from the discussion of the paper, just to give you a sense. You're looking at first generation production and second generation left with mitigation needs. So you have A1 and B1, so this creates $12 and this creates $4 worth, whereas the emitted carbon here is very high from the rich countries and very low from the poor countries. So when you go into the second generation which created the wealth and the emission is willing to pay more based on what they know, and the poorer countries which didn't contribute as much historically are willing to pay less for mitigation. So illustration of the game structure then is participants A1 and B1 provide effort at a certain piece rate. In the example, A1 earns $12 per task and B1 earns $4, creating wealth and emissions. Participants A2 and B2 inherit the wealth of their predecessors and use it to mitigate climate change. This is the basic structure of the game that is set up. So if you look at the share of the costs paid from 0 to 1 on a scale normalized, and historical emissions on a scale of 0 to 1 normalized as well, there is the history, there is the baseline in these red dots, and there is the 45-degree line, which is correlation of 1 on share of costs paid and historical emissions. Share of the climate change mitigation costs paid by the proposer in the history treatment, so the blue crosses, and in the mean baseline, the red crosses, across different levels of the proposer's historical emissions. So proposer has got different levels of emissions, and this is the baseline scenario where the relation between share of costs paid is not very heavily dependent on the emissions, historical emissions, whereas in this case the emissions increase, share of the costs paid increases as well, although not on a 1-to-1 scale. Okay, so each marker represents a different outcome created by a first generation pair of participants. Blue and red solid lines indicate the baseline let me read it again. Blue and red solid lines indicate the best linear fit for the data. Okay, so that's the regression line, and the 45-degree line indicates how costs would be divided if costs were always divided proportionally to historical emissions. That's fairly straightforward. So that's how the results play out in this simple game theoretic approach, but the discussions give you a few more details on what the results actually mean. We found that when participants with greater historical emissions were informed about it, they offered to pay a larger share of climate mitigation costs. As you know, Europe behaves very differently than the US when it comes to such things, about what to do about climate change going into the future, how to own up to the past emissions, and so on. And US behaves very differently, and within US, California will be very different than Texas, and so on and so forth. So one has to be aware of these region-specific behavioral aspects as well. This behavior is consistent with the collective responsibility, even though the generation that pays for climate change mitigation and the generation who created climate change never interacted in this case. Our findings suggest that citizens in developed countries may accept paying more for climate change mitigation if the link between past emissions, present wealth, and present climate costs is made clear to them. This is where I said rational ignorance may play. If you look at the IPCC negotiations, 1990 is used as a baseline to count emissions, so that the claim is that the emissions before that were unintentional, that the rich world didn't know that emissions were going to cause climate change issues. Well, there have been literature and reports of how increasing CO2 is affecting climate already from 1896 to 1912, 1937, 1950s, 1970s, and so on. Even 1980s, it was fairly obvious that's what is happening. But nonetheless, it was somehow used to argue that only after 1990 we've been fully aware. So already this is something that one has to be mindful of when we decide that maybe the generations will pay for the wealth they inherited and the emission that went with creating this wealth. Our findings suggest that citizens in developed countries may accept paying for more for climate change mitigation if the link between past emissions, present wealth, and present climate costs is made clear to them. Is there somebody still who doesn't understand this? That's the question. Recent advances in climate science enable policymakers to communicate this information with greater accuracy than ever before. So climate skepticism, climate denial goes on. As I said, US, Australia, Europe, Canada, everybody behaves differently. A possible interpretation of these findings is that in the history treatment, information about the predecessor's carbon emissions provided a salient cue for the fraction of costs that the participants should cover. They discovered they inherited the wealth, but that came with emissions. Historically, they may say, oh, then we should pay for it. This cue, which was unavailable in the baseline, might act as a focal point or an anchor, which are known to affect decisions. You have to read these papers by Daniel Kahneman and others on how decisions are made with a focal point or an anchor. So here it's argued that historical emissions knowledge can act as a focal point or an anchor. Salience might be especially important because there are multiple Nash equilibria in the game. I won't go into this detail, but you know John Nash, maybe from the movie A Beautiful Mind, but Nash equilibria in this kind of multi-party negotiations are something that are important in considering such game theoretic approaches on how multiple outcomes depend on various factors. Future work could study whether information about historical emissions affects decisions because of salience and whether decisions would be affected by other kinds of salient information, including irrelevant anchors. Okay, so throwing in irrelevant anchors can affect the salience of the information itself and of course the decisions that would then come out of them. Amid the COVID-19 pandemic, countries have increasingly struggled to reach the targets set by the Paris Agreement as the world nears the point of no return to stop disastrous climate change and needs costlier investment in high-risk, high-return investments. Harnessing global support for climate change mitigation efforts will be an increasingly pressing challenge. In other words, we are already behind in terms of where we need to be in drawing down our greenhouse gases, especially to meet the global warming targets of 1.5 degrees C by 2100 or 2 degrees C by 2100. Okay? Communicating to the public in developed countries the relationship between their present wealth and the carbon emissions of the previous generations may increase the support for more ambitious mitigation efforts in these countries. Is that true? It depends on how you think about it. If you look at the negotiations that have gone on for 25 years under the UNFCCC and the fact that the emissions are not bending, the curve is not bending at all year after year. There was a dip for COVID, for example, and then the stimulus funds have come in to recover the economy from COVID slowdowns, which have basically increased the emissions back to the pre-COVID levels. Anyways, we expect peak emissions to be reached in the 2020s, but we also rely on technological promises of renewables, their deployment, their contribution to energy, and carbon capture, etc., which are not certain to be met on time anyways. So let me stop this for a second and start because there's somebody at the door. Okay, sorry about that. So just to conclude, Nash equilibrium basically says that in the negotiation, each participant may decide to stick to the original strategy to get the best outcome. Then that's how it will work. But Nash equilibrium also says that this strategy is to optimize your negotiating position based on what other participants are trying to do. So these are kind of details that always are used in economic modeling, so you can read the details in the paper to understand how that would affect the basic fact here that historic emissions do affect how much contribution a country will make to its role in mitigation of climate change. And the hope is that the historical emitters, the developed world, global north, will pay more for mitigation, but this is not as obvious as this paper and this game theory would indicate. Nonetheless, we have to keep on negotiating, and we keep on arguing that we are not moving fast enough. For example, the nationally determined contributions were updated. Already there are reports showing that even the updated nationally determined contributions to the global Paris Agreement is not enough to stay on track for net zero by 2050 or the global warming targets by 2100. So this is a constantly evolving process. Nonetheless, game theory approaches do tell us how players are participating in this global negotiation. Okay?